I guess so.
We're
Now
recording.
it's
I started
actually
recording
good.
before I even asked you that question. So, okay.
Wow.
So let's get started. Today we are looking at lesson 4, rational expressions. This is going to use the stuff that we've talked about in lessons 2 and 3, factoring and more factoring. So, with that said, Mrs. Contreras, what is a factor? We know the answer now.
Factor is what the two things you can multiply, two or more things you can multiply to get a thing.
Two or things. What was that word that started with an M?
Multiply.
Multiply. That is the word of the day, one could say. I'm sure we'll have plenty of words of the day, but that is one of our words of the day, is multiply. Because when we say something has a common factor, we're referring to some sort of expression that is broken up into the product of things. Okay? When we say terms, we're talking about when something is separated by addition or subtraction, but once again, subtraction is just addition of negative numbers. So we have here common factors, right? The numerator of this rational expression, rational meaning ratio, meaning fraction, there is a common factor between the numerator and the denominator. What is that common factor here?
5.
5. So what can we do with that 5?
We can cancel it with fun laser noises.
Are you ready?
Pew! Pew!
All right, we'll get to what I want to say in a second. All right, but now that we've canceled them, now that we've gotten rid of them, what are we left with?
7.
7, right? Which totally agrees with how, other ways you could do this problem. What's another way you could solve this problem? Simplify this expression.
Well, you could have 5 times 7 equals 35, and then divide that by 5, and you get 7.
You get 7. So this idea of canceling out common factors is in agreement with other ways we might do math. And that's kind of the goal of math, is things are going to get interweaving. You're going to have lots of concepts, and they need to agree with each other. If they don't, that's a big problem. So let's go over to this other problem here. Common term. Can I get rid of these 5s? How does that make you feel?
Cringy.
Cringy. That is the word of the week, apparently. We're using that a lot. All right, the 5s. They cannot be canceled. Can you talk to me about a reason maybe why not?
Well, if you cancel the 5s like that, then you're saying that 5 plus 7 quantity divided by 5 is equal to positive 7. And I really don't think that's true.
What is 5 plus 7?
5 plus 7 equals 12.
Okay.
And 12 divided by 5 is nowhere close to 7.
Right, saying the sentence 12 divided by 5 is equal to 7 is like anarchy. Right? This is not
tiers,
true.
Multiple tiers.
The conclusion we need to make here is that we cannot cancel out terms that are common from a numerator and a denominator. We can only cancel out terms that are common factors. Common terms is not a valid way to simplify a rational expression. That's what we're going to be looking for. We're going to be breaking things down into their factors. And then if there happens to be a common factor, we can get rid of them. But otherwise, we can't. So let's look at this rational expression. Right? Up here we have just rational numbers. Down here we have rational expression. We got variables going on. What should we do? I want to simplify this thing. Ideally, this is simple. More simple.
We should probably factor, since that's what we've been practicing.
Now let's do it. All right, so x squared minus 4x minus 12, what does that factor to?
X minus 6, x plus 2.
All right, and just in case, we always want to double check that we did factor correctly. Once again, factoring can be difficult, but checking your answer isn't necessarily. X times x squared. Negative 6x plus 2x is negative 4x, and negative 6 times 2, that is negative 12. So we are good on the top. How about this bottom?
The denominator, that's a difference of squares. So we can do x minus 2x plus 2.
See, you do the minus first now too because of me. Aha. All right, but maybe you also did that because you have this, you saw the future. But what can we cancel out here?
Oh, we can cancel. There's an x plus 2 in the numerator and denominator, so we can just laser that away.
We can get rid of it. All right, so what are we left with? We got x minus 6 over x minus 2. All right, but I have a really important question. right? Currently, we are saying that x squared minus 4x minus 12 divided by x squared minus 4 is equal to x minus 6 divided by x minus 2. But I disagree with that. These are different somehow.
Well, what happens when we plug in -2 for x on the left side and on the right side?
So let's do it on the left-hand side. You'll often see me use this notation, LHS, and we'll also do it on the right-hand side. Let's plug in, you said -2?
-2, yeah.
All right, so let's see, we got, that's gonna be 4 minus 4 times -2, that's -8, right?
Mm-hmm.
So we're gonna have a plus 8, minus 12, nothing's happening there really, divided by, what do we get?
We get -2 quantity squared, which is +4, minus 4, so we get a 0 in our denominator, and then our brains break.
And what is 0 divided by 0?
Indeterminate.
Yeah, we actually have a name for it. It's called indeterminate. And you'll explore this, pre-calc students, you'll explore this in depth in pre-calc C and in your calculus class. But in general, when you get 0 divided by 0, our brains explode, and we can't do it. We can't do it. You have 0 groups, and you want to divide it. You have 0 things, and you have 0 groups, and you want to divide those 0 things among your 0 groups. That sentence doesn't make sense, right? And I also encourage you, if you have an iPhone or you have Siri, to ask Siri, what's 0 divided by 0? That'll be a little surprise for those who are able to look into that. What is 0 divided by 0 according to Siri? If you know who Cookie Monster is, you'll have a great time. All right. How about this other side? What do we have? -2 minus -6? That's
-8.
-8. And -2 minus 2?
-4. So that simplifies +2.
All right. So what I'm showcasing here is that these two expressions are not the same for the very unique number -2. Okay? These two expressions, right here and right here, they are the same for all numbers except for -2. Right? If you plug in -2 into the first expression, you get something called indeterminate. You get something that doesn't make sense. If you plug in -2 into the second expression, you get 2. So when we simplify expressions and we get to the final answer, the most simple, we need to add to our expression what x is not allowed to be. X is not allowed to be -2. Because I didn't say, like, cancel out everything. I said rewrite this expression in a new way that's more simple, but still maintains its integrity. So x minus 6 divided by x minus 2, with the added addition that x cannot be -2, now the expressions are identical. So as we simplify rational expressions, we need to make sure that at the end, we are excluding problem points. Those problem points end up being the things that you canceled out. Look at that. We cancel out x plus 2, right? When is that thing 0? That thing is 0 at -2. So the things that you cancel out end up being problems. So make sure when you're done to specify that -2 is not allowed. Let's continue. All right, let's simplify this thing. Ms. Contreras, I need you to take it away. I can't literally give you the pen, but what are you thinking?
Well, I think that we have some things we can factor again. So we have in our numerator on that first part, 4x that's a greatest common factor. So we got 4x times x minus 1. And then I'm just going to notice that there's a 4x in the denominator. So I like that. That's nice.
Ooh, yeah, I like that you're saying that out loud. Cool.
And then for the denominator there, I have x, what is that? X minus 1, and then x plus 3.
All right, let's just double check it real quick. -3, -1, and +3 is a 2. Yep, we're good there.
Cool. And then for the numerator on the right, we have x, what is that? Minus 2 times x plus 3. And a quick check for that. And we should be good.
That's
and then
good.
we got that 4x that we liked.
Awesome. Cool.
So now we can cancel stuff out with some laser noise, bam, cues.
Before we do that, does this change the problem at all? Does that multiplication symbol change the problem at all?
It's a good question because with fractions, sometimes our arithmetic gets all wonky, right? We need to have like common denominators or be careful about flipping things. But for this, since it's multiplication, you just multiply across the top, multiply across the bottom, and we're good to go.
Yeah, let's just like refresh everyone's memory from whenever you dealt with fractions for the first time. A over B times C over D. Right, whatever A and B and C and D are. As long as B and D are not 0. But when we multiply fractions, we just multiply right across. AC over BD. So essentially, we can get rid of that thing. Oh, didn't mean to get rid of that much. And then just extend this thing along, and it's just one fraction. So let's do some laser noises now. Ready?
All right.
I'm like thinking Star Wars the whole time.
Oh, yeah. But then there's like the pew, pew, pew.
All right, we're left.
That was my lightsaber noises. What color lightsaber would you want, Mr. Kirk?
I would definitely want yellow. Very uncommon lightsaber, but in all the video games, it's my favorite one. All right. X minus 2. Wait, let me ask you, what lightsaber color would you yield or wield?
I think I really like green.
Green, okay. Oh, who's green? Was that like Obi-Wan?
No, that was Qui-Gon. But then that was Luke's
died in the first one.
second one. Yeah.
The prequels.
But I think it's more like it seems tended to be more wielded by the gray, but it actually only depends on your kyber crystal, right? So like, meh.
Oh, you're getting a little bit out of my wheelhouse when it comes to Star Wars. Midi-chlorians or whatever they're called. Okay.
Oh yeah, midi-chlorians.
Okay. We got X minus 2. Is this the correct simplification?
Yes and no. We did our canceling correctly, but now we need to make sure that we say what X can't be, which is from all of those things that we canceled out. So X can't be 0.
Okay.
X can't be 1.
Okay.
And X can't be -3.
Beautiful, right? Because if we plug any of these numbers into the original expression, we'll get divided by 0. We may get indeterminate, 0 divided by 0. But we also might just get like 1,000,000 divided by 0. And then it explodes and your brain melts. But if you plug in 0, 1, or -3 into this final expression, you get real numbers. You get -2, you get -1, you get -5. Right? So X minus 2 is not perfectly identical to this original expression. It is very close. We have to cancel out these things. Thank you for adding that there at the end. Let's continue. Ooh, dividing fractions.
Wow.
So,
this feels like we could do some flippy.
Flippy? Talk to me. What do you mean by flippy?
Flippy that's the way that you can like talk about, instead of saying something boring sounding like multiply by the reciprocal, you can just do some flippy, where you multiply by the reciprocal of the denominator.
Okay.
But it's actually isn't it secretly just multiplying by 1?
Yeah, because like you can't just multiply an expression by the same, like just anything. You can only multiply by 1. Otherwise, you're changing the expression. So you want to multiply flippy style. You want to multiply the top and the bottom by the reciprocal. So let me go ahead and write that. X squared minus 2x. You want to do this. But you can't just multiply this fraction by this. Like you got to multiply by 1. So we're going to write the same thing on the top and bottom.
This like quadruple decker sandwich now.
Yeah, that is intense. But we like the whole point of multiplying by the reciprocal is not to make it more complicated. This looks more complicated, but what happens? What's happening to the denominator?
The denominator, that all simplifies to just 1.
Yeah. Bang, 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 no. Right? It all just disappears. We have simplified this problem. Before I do anything, let me just recognize, I said this out loud, but this expression, something divided by itself, that's equal to 1. I just want to add that on the page for those that are writing along. All right, so cool. So the denominators just both completely went away. Instead of having one large mixed fraction, now we have 2x over 3x minus 12 times x squared minus 6x plus 8 over x squared minus 2x. Cool. All right, we're done. Let's move on. What do we need to do?
Factor.
Let's do it. Let's just factor. Let's knock it out. 2x. Over here, I see an 8. I'm thinking forward 2. And it's positive, so I need a -4 and a -2, which is going to get me to -6. So, oops. We got x minus 4, x minus 2. And while I'm at it, I'm combining these fractions because multiplication, you're just multiplying straight across. Then down here, I'm gonna go ahead and get rid of that GCF, x minus 4, 3 times x minus 4. And then over here we have an x, and that people might be hating me for like writing it parenthesis x parenthesis, but get over it. And we got x minus 2. I see some laser noises ahead of us.
Yeah, here we go.
Here we go, ready? Are we done?
No.
2/3. That's actually really cool because no matter what you plug into this expression here, you will get 2/3. Plug in 1 million. Plug in -47. You will get 2/3 every single time, except where?
Well, at x equals 0, because then you get undefined, right? And then x equals 4 and 2. And I didn't do those in order.
I don't think we're missing any because we're looking at where we cancel. But boom, 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 boom. All right, let's go back to the original problem too. All right, because we got some divided by zeros all over the place. All right, this can't be 0 right here. 3x minus 12, that's divided by 0. So that's a 4. We're good there. On the numerator here, it can't be 0, and it can't be 2. Cool. And the denominator down here, it can't be 4, and it can't be 2. We got them all. Right? There's a lot of repetition here. So we are good. Right? Look at where you're canceling things. Also, come back here and reference and just make sure that you're not missing anything. We don't want any divided by 0 in this final expression. Right? This circle over here and this circle right here, these two are the same expressions except for at 0.2. All right, let's continue. All right, we've been dealing with fractions. And we've dealt with simplifying fractions and we've dealt with multiplication of fractions. Let's look at the addition of fractions. Can I add these two fractions together?
Yes. Because they have a common denominator, so we have no problem. We're speaking the same language when we're talking about these two different terms.
So we have 4, 6x plus 5, 6x. We have 9 6x's. And then let's go ahead and simplify this. Common factor. I'm actually going to write it out just so everyone we're clear what I mean. Right? The top 3 times 3, the bottom 2 times 3 times x. We have a common factor of 3. So we got 3 divided by 2x. All right. How about over here? Do you see an issue with this thing?
No, because we have the same common denominator and subtraction is just addition secretly.
All right, so let's do it. We got 4 minus 2x minus 3, all divided by x plus 3.
Wait.
What?
Hang on. Don't we need to distribute our negative?
What do you mean?
Well, when we have 4 minus 2x minus 3 versus 4 minus the quantity 2x minus 3, shouldn't we get...
Sorry.
Shouldn't we get 4 minus 2x plus 3 in our numerator?
Absolutely. Earlier you had said that subtraction is just addition. So we're adding negative 2x minus 3. Right? So that negative is, in fact, as you're saying, hitting that negative 3 as well. So we need to go ahead and make that plus. What I like to do actually is, I'm going to go ahead and get rid of that. I like to put parentheses. All right, parentheses will be your best friend. But that will lead to a plus. So 4 plus 3, that's 7. All right, minus 2x. How do you feel about my constant leading the variable?
That's totally fine.
I agree. Even my like brain that needs to be organized is fine with that. All right, cool. I think we're done there, right?
Yeah, I think that looks good.
All right, so be careful about these negative signs because they will burn you later if you're not careful. All right, how about these? Can we add these things?
No, because we don't have a common denominator. So we need to make it common denominator.
We need to make it so.
Need to make it so.
Make it so. All right, so how do we find a common denominator? I know a few ways.
Well, we talked about like GCFs, and then they had like a friend, and I think it was called LCMs, but I forgot what that stands for.
Least common multiple. Right? We want to look and see what the least common multiple is between 6x and 8x. Right? What is the smallest number that, or expression, that these two expressions go into? Right? We could just multiply by 8x over 8x to find a common denominator and 6x over 6x here. Don't do that. Don't be that person. Now you're going to have x squared in the denominator. You're making things more complicated. Try to make things as simple as possible. And to do that with fractions with different denominators, we want to multiply by the least common multiple. So what is the least common multiple for 6x and 8x?
I think it's 24x.
Yeah, 6x goes into 24x, I believe 4 times, and 8x goes into 24x 3 times. Right? So what do I multiply 6x to get 24x? Let's multiply by 3 over, no, not 3 over 3, my bad. I just said 4 over 4. Right? Once again, notice I'm multiplying by a fancy version of 1, 4 divided by 4. And over here, I want to get that 24x in the denominator, so I'm going to multiply by 3 over 3. Not just 3, but 1. Right? That's the only thing you're allowed to multiply an expression by so that it doesn't change. You can add 0 or you can multiply by 1, but nothing else.
Those have names, right? Identity, property of multiplication. Identity, property of addition.
Ugh. Those words give me nightmares.
I used that like last night in a proof.
They are important. Okay, so 4 times 7, that is 28.
28.
We get that 24x on the bottom. I know we're making this more complicated, but it is for a point. It is so that we can add these two denominators, or add these two fractions, because we're making it so. And then 5 times 3 is 15. I think we end up getting let me add an equal sign here, just so I'm aware that I'm writing something that's equivalent to the previous line. And then I'm going to add another equal sign here. I think we can make that 43 over 24. Are there any common factors between 43 and 24x?
I don't think so, but I could be wrong.
43 is prime, I think, right?
All right, cool.
Yeah, so I think we're good. 43 definitely does not go into 24. Right? Common factor of 1, but we don't do anything there. Cool, I think we're done there. So we've simplified that. All right, let's do it with some more expressions down here. We got 3 over x minus 3 minus 5 over x plus 2. We want to find the least common multiple of these two denominators. What is an expression that x minus 3 goes into that x plus 2 also goes into?
I think we need to just use both of those denominators as our factors.
Right? Like we need an expression that has x minus 3 in it. And we need an expression that has x plus 2 in it. So that's our LCM. Right? We could put a 4 in front of here, but that wouldn't be the least common multiple. That would be a more common multiple, an MCM. X minus, that was really dumb. So that's our LCM. So let's go ahead and get that LCM on both these fractions. I'm going to multiply this one by x plus 2 over x plus 2. That is 1. That is the, what do we call it? The identity property of multiplication. Correct me if I'm wrong.
That's good.
Cool. And then we have x minus 3 over x minus 3. And then I believe we get 3 times x plus 2 over x plus 2 times x minus 3. I'm very aware that we're making this more complicated, but we are turning it into one fraction, which has its benefits. And then over here, we're going to have 5 times x minus 3 over x plus 2 times x minus 3. Cool. All right, let me go ahead and do, we don't want that to be involved. All right, we're done.
I don't think so. I think we can simplify that because we have common denominators. That was the whole point.
Exactly.
We get together.
All right, so we got,
distribute out so that we can combine the terms too.
Yeah, let's knock a few steps out in one. Let's go ahead and distribute that 3x plus 6 minus 5x minus 15.
We need parentheses.
Mm-hmm. And then we got that x plus 2 and that x minus 3. I have high hopes here. All right, what is, we got 3x minus 5x. Let me add my equal signs.
Very responsible.
All right, 3x minus 5x, that's negative 2x. And then we got 6x minus negative 15. Oh, but that's a big number. 21?
21. 6
Cool.
plus 15. 21.
That's like maybe the biggest number right now.
It's a pretty big number.
I haven't seen a number. Oh, no, 43 is bigger than that. Never mind. 43 is the biggest number right now. All right,
And that's
cool.
how old you are, right?
And do we have any GCFs in the numerator and the denominator?
I don't think so, because negative 2x plus 21, that doesn't have any common factors in it.
I think we're good.
In those two terms. So we're good.
Awesome.
Oh, that's a smiley face.
All right. Did we intend to do number 5?
I don't remember.
Yeah.
Let's just let them do it. See what happens.
Yeah. Yeah. All right. Hopefully, you get the right answer. Let's proceed. All right. Ooh, I love this. All right, we want to simplify complex fractions. So now we're going to take what we just did, simplifying fractions, and simplifying fractions with different denominators, and we're going to squish them into the same problem, sandwich them into the same thing. All right, so there are 2 ways to do this. And Mrs. Contreras, I want you to kind of intuitively do this the way that you might think someone who's never seen this before might do this problem.
I'll probably try to take the smallest, work in chunks. So take the numerator and try to simplify that.
Okay.
Take the denominator and try to simplify that.
All right, let's do it. Let's do it. So we got x divided by 4 plus 3 divided by 2.
So then to get a common denominator there, I just need to multiply the second term by 2 over 2. So that gives me x plus 6 over 4.
Yep, and let's go ahead and x plus 6 over 4. Let's go ahead and just do that.
All right.
Yep.
And then in the denominator, I need to multiply the first term by x over x, so I get a common denominator of just x. So I have negative.
Am I writing this correctly?
Yeah. X minus 3, yes. Yeah. Over x. Good.
All right. So we just did what we just did previously. We combined 2 fractions that have a different denominator. And then let's do some flippy.
Sounds
All right,
good.
let's turn this into x plus 6 divided by 4 times the reciprocal of the denominator. Right? I'm not writing the denominator twice flipped this time because that's a lot of writing. I don't want to do it. Right? But I know it's happening. I know why I can multiply by the denominator. All right, and I hope that you do too, to those watching. All right, and then we got, let's go ahead and multiply across. X plus 6 times x. And then a 4 times 2x minus 3. And I believe we're done.
I think so.
I don't see any common factors. Everything's factored, which is nice. Like you could expand, but usually we want to keep things factored for solving purposes. Yeah, I think we're good there. All right. Let's look at method 2 though. This is, in my opinion, the far superior method. All right. I want to get rid of denominators. What number could I multiply x divided by 4 to get rid of it? To get rid of that 4 in the denominator?
Multiply by 4.
Multiply by 4. But if I do that to the top, I also need to do it to the bottom.
Correct.
All right. What number do I need to multiply 2 by, or 3/2 by, to get rid of the denominator?
Well, 4 still works.
Yeah, right. 4 still works, right? I need to multiply by 2, but 4 contains that 2. Right. This is not a fraction. There's no denominator to get rid of. Right. What number do I need to multiply, or what expression, I guess, do I need to multiply 3 divided by x by to get rid of its denominator?
X.
X. All right, so if I multiply the top and bottom by x, right, this works because I'm multiplying both the top and the bottom by a number.
So it's still 1.
Yeah, it's still 1. This is still a fancy version of 1.
Fancy one.
4x over 4x. No matter what you plug in for x except for 0, it is 1. So let's see what happens. What's 4x times x divided by 4.
I think that's an x squared.
I agree. Yeah. Cool. All right. What's 4x times 3 halves?
I think that's a 6x.
It's a 6x because the 4 and the 2 are going to turn into a 2 times 3 is 6x. And you said positive 6x. Wonderful. And then what's 4x times 2?
Oh, that's 8x.
And then what's 4x times negative? So I'm going to go ahead and add these arrows. I'm distributing. And then what's 4x divided by?
Negative 12.
Negative 12, right? So boom, boom, right? What we just did, I like to call, and the magnet teachers like to call. I did not invent this. I don't want to give myself credit. The super denominator killer method, right? Because what we just did is we found a number which is the least common multiple of all the denominators. We found an expression that bam, 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 kills all of the denominators. One expression that handles every single denominator in this mixed fraction, in this complex fraction. And I crossed that 2 off. I shouldn't have done that. Right? This 4x, this LCM, kills all the denominators. Bam, bam, bam. We're done. And you might like this method over here, method number 1. That's valid. Our method 2 is another way you can approach these problems, because our goal is to get rid of the extra denominators. Here we have 4. Multiplying by 4x on the top and bottom gets rid of all 4 of our denominators. Leaves us with 1. And then I think we're close. We just need a factor. Right? This leaves the factoring for the end. The other one, we did the factoring at the beginning. Ooh, what's here? We got a 4, right?
Mm-hmm.
X minus 3. And we got the same answer, right?
Yes.
Wait, did we? Why do we have a 2 here? Should that be there?
Yeah, you should.
Oh.
8.
Nice.
Yeah.
Nice. Okay, cool. That 2 is there. I got worried there for a second. But that's something that I want everyone to do, is reflect on your answer. Does it make sense? And mine didn't, so I knew to look for a mistake. All right, the super denominator killer method. I actually want to use that. I want to use that in number 6.
Mm.
So the first thing I want us to do, like step 1, factor. Let's just factor everything. We got a 2 here. What is this denominator factor to?
It's 3 times x plus 5.
Cool. All over.
2 over x plus 5.
Yeah, that's good.
Plus 1 over 4 times x plus 5. Wow, it's like that x plus 5 is just like cropping up everywhere. Interesting.
It's almost like as teachers, we intentionally chose numbers that make things make more sense.
What?
All right, so let's continue. Or before I put an equal sign down there, let's find the LCM of all these denominators. Right? What do I need to get rid of here?
We need a 3, a 4, and an x plus 5.
Yes, we need a 3, a 4, and an x plus 5. So that means I think we need a 12 and an x plus 5.
Sounds good.
And then we need to multiply the top and the bottom by 12 times x plus 5, or we're not multiplying by 1, which is a huge like mathematical blunder. All right, so let's see what happens. Bam, 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 bam. We just killed all the denominators.
Wow, so much death. What can men do against such?
All right, so this 3. This 3 is going to get rid of the 12 and bring it down to a 4. So we're going to have 4 times 2, which is 8, times x plus 5. Oh, no, the x plus 5 disappeared. Oh, wonderful.
Yeah, it's not even there.
Yeah, it's not even there anymore. The x plus 5 killed that x plus 5. So boom, that became a 4. Right? And over here, the x plus 5 got rid of that. And then this 12 is causing this 4 to become a 3. So we're going to have a 3 there. And we got a 24 there, right?
Mm-hmm.
2 times 12, because the only thing that's getting canceled here is the x plus 5. The 12 stays. 24 plus 3. 8 over 27?
8 over 27. That's like a perfect cube over a perfect cube, and that's like kind of nice.
That is a perfect cube. Let's just like write it like that. 2 divided by 3 cubed. Quantity cubed. Excellent. Hey, just a quick, are we recording?
Mm-hmm.
Okay, good. Cool. All right. 3-second coffee break. 1, 2, 3. All right, cool. All right, so super denominator killer, it is now in your pocket. You can use that to simplify rational expression. Let's solve some equations.
Ooh.
All right. So I have opinions about how to solve these, but I want to hear what you want to do, Ms. Contreras. What do you want to do
Well,
here?
I mean, like, I like factoring. I think that is probably a good choice to get started. And then, but I guess if you didn't want to factor, you could just multiply
Yeah, multiply
by
both
the
sides.
denominators on both sides.
I like that. My strong opinion is I also agree that we should factor first. I think like 9 times out of 10, 99 times out of 100, 46 times out of 47, you should factor the problem first. That is like step one in every math problem ever written, right? And if factoring is not part of a math problem, then you just skip step one. Right? Step one is factor, I think always, in every math problem. So let's do that. We got x minus 6 over, we're going to have a minus, we're going to have a 3 and a 2, right? And that 3 needs to be the positive one. And then over here, top is already factored. We have a negative 3, we have positive 2, so I think oh, look at that. The advantages of factoring.
Hey.
I think that needs to be a minus 1. Yeah, cool. We have x plus 3 in both sides of this equation. So what do you want to do?
Well, so if we get rid of it, right? Like if we multiply by x plus 3 on both sides, right? Because that's a valid move. Then do we?
We're no longer in expression land. We're in equation land. We can do things to both sides of an equation.
So then we can cancel them out.
Bang, 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 bang.
And then can we go on our merry way? Can we just proceed?
I think so, because I mean, if negative 3 ended up being an answer, what would have it done to the original problem, though?
That would have been undefined equals undefined, which
yeah, which like one person might. This is philosophical. Does undefined equal undefined?
I don't think
so, right?
You can say that.
I don't think we can not necessarily not say it. I think that we don't have enough information to claim that undefined equals undefined. Right? I think that we need to explore more in the future what it means to be undefined. Right? And that's a calculus question. And we'll explore that in a year or two. What does it mean to be undefined? Think about that. Maybe write about that in your journal.
Yeah, because there's different kinds of infinities, right?
Yeah, right. Because when you divide by 0, it means you're getting closer and closer to 0, right? So you're dividing by 0.001, 0.000001, which means you're getting a big number. So who knows what the undefined we're talking about is? Undefined does not necessarily mean undefined. So in this stage in your math career, we're just going to say it's garbage and throw it away. All right, it's in the trash.
You don't understand it. It doesn't matter.
You will understand it. Now, working with the numbers that we're working with, we're just going to say, let's not concern ourselves with that. Don't go and say that like undefined is equal to undefined.
It's for future you.
Yeah, if you learned everything now, then you'd have nothing to learn in the future, which would be quite an unfortunate fact. Let's continue. X minus 6 over x minus 2 is equal to 3x over x minus 1. What do you want to do here?
I mean, cross multiply.
Instead of cross multiply, let's not because we want to interact with other people in a mathematically educated way. So instead of saying cross multiply, let's just multiply both sides by the least common multiple of both sides. Because that's what's allowed in math, right? We can multiply the the right-hand side in this case, where I'm writing, by x minus 1. If we do that, we got to do it over here. And then let's go ahead and multiply both sides by x minus 2. And if you've done cross multiplication before, you know that this is exactly the same thing. But we're doing it in a way that we understand better. It's not just words that solve our problems.
I mean, it kind of looks vaguely like super denominator killer, like what we're doing.
Bang, 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 bang. We got x minus 1 times x minus 6. And that's going to be equal to 3x times x minus 2.
Expand.
Expand. All right, so let's go. I'm going to go ahead and add my equals. No, wait, my equal sign's right there. We're not dealing with expressions. My bad. I'm going to put a little arrow just so it's easy for those to follow. We're going from down here to up here. And we got x minus 1 times x minus 6. That is going to be x. There's going to be a plus 6. That's an x squared. And I think it's going to be a minus 7.
Mm-hmm. X.
7x, yep. And then over here we got 3x squared minus 6x.
Sounds good.
Cool. So now we're just like, this is the part where viewer, you can hit that 2 times button and just proceed through our attempted algebra. Let's move things around. We're going to get, what do you want to do? Move things to the left-hand side or move things to the right-hand side?
Well, since there's a 3x squared on the right, I just want to, that's bigger than x squared. Yeah, I want the 0 on the left. And then we can have, what, like 2x squareds plus 1x. So just plus x.
Let me go ahead and give myself a little more room. 0 equals 2x squared. And then we have a plus 1x.
Uh-huh.
How do you feel about that 1 being there?
I'm ambivalent.
Okay, sweet. All right, we're here. We need 2 numbers. Oh, we got to do some factoring here. We got to do a little bit more interesting factor. We got 1 and 2, 2 and 1. We got 1 and 6, 2 and 3. I have flip-flopped this side, so I don't need to flip-flop this side. How do
we
we
need this one to be positive 1.
We need
so I think we need what, like 4 and 3?
Yeah, so
like
we
times
got
2 and 1 times 3.
Yeah, 2 times 3 and 1 times 2. So we're going to have 2. I feel like I might be doing something wrong. That's a 6 and a 2. That's not what I want. Control Z, Control Z, Control Z. Control Y. All right, we want this one, right? 1 times 3 and 2 times 2. I bet.
Yeah.
1 and a 2. And a 2 and a 3. Throw an X there, throw an X there. And then we need the 4 to be bigger than the 3.
Mm-hmm.
So there we go. Cool. And we could always check if we're concerned. All right,
That equals 0.
Yeah.
Yeah.
Let me not forget that. All right, cool. So when does 0 property, when does x plus 2 equal 0?
When x equals -2.
Okay. And then when does 2x minus 3 equal 0?
When x equals 3/2.
3/2. Boom.
Nice.
Good stuff. All right, so we got our answers. Cool.
Cool.
And I think we're good to go, right?
Yeah.
Don't think we're missing anything there. All right. Do you want to do this one?
Versus letting them do it.
Yeah, what do you think? I know we talked about it, but once again,
I think
I'm
it's
like,
about that time. I think we can just
I think
see
so
if we
too.
can come up with our solution.
Yeah. All right. What I want everyone to do, though, is when you do number 8, which you're going to do in just a second, check your answers at the end. Check your answers at the end, because this entire time we've been talking about there's this issue when we divide by 0. So when you get your answers at the end here, plug them back in and see what you get. All right, I think we can close this video out here. Is there anything you want to add there, here at the end, Ms. Contreras?
I think it's good.
Cool.
Best wishes on solving that last one.
Yeah.
We'll see how you do.
Sweet, I'm going to get that right. Well, they've already solved it, hopefully, by now. We'll put the question in before this. All right, how are we going to exit this video?
We can just do like we can do the hand in the camera. Ready? 1, 2.